Physics chapter 19, theory video 7, the meaning of temperature. So now you have learned and discussed what temperature means in your ordinary levels, and also in AS level there were some mentionings about the temperature. So now um, you know that there are different ways how temperature can be measured. So in that sense, you know that temperature is measured by the transfer of thermal energy. If it is a liquid in glass thermometer, the liquid expands because the thermal energy is transferred from whatever the liquid or the gas or whatever it is that you measure the temperature of. From that thermal energy is transferred to the liquid inside the gas chamber, inside the glass chamber, and that expands and that gives us a reading. So the thermometer, when you increase, now for example, if you boil some water, after some certain time, after certain periods of times, you can actually see the thermometer becoming or giving a higher reading. That is because the water has transferred energy from it to the thermometer, right? So the key idea that we need to learn here is thermal energy is transferred from a region of higher temperature to a region of lower temperature, like diffusion, the definition of diffusion. So then when the water starts to boil in it, the temperature will give us a reading of 100 degrees Celsius, and it stops rising. Why is that? Because you know that at 100 degrees Celsius there is no longer energy being transferred into the thermometer. So the thermometer remains constant. At that point, you know what happens. The state is changing, right? So then basically, forgetting about water, what does this temperature, what does the reading tell us? The reading tells us that the thermometer has reached the temperature of 100 degrees Celsius. That means the temperature of the thermometer has increased to 100 degrees Celsius as well, right? It is what we need to understand is the thermometer is not actually showing the temperature of the water. It is actually showing the temperature of the thermometer, right? You understand that. So because the temperature of the thermometer is rising only, it shows that, right? It doesn't show the temperature of the surrounding. Because of the surrounding, it is getting heated up. So because it is getting heated up, its volume increases. As a result, it shows us a higher reading. So that is what we need to understand. So energy is getting transferred from a hotter object to a cooler one. The temperature of the water initially was greater, right? And then it continued to rise. So then now just imagine what would have happened if you took a thermometer which was at 30 degrees Celsius and dipped it in icy cold water. Then the energy contained in the thermometer would get transferred to the outside. So as a result, you would see the reading going lower. So we can figure out in which direction the energy is flowing. If the two objects are in the same level, if they have the same energy content, then it would not flow. It would have the same, it would give the same reading. right? So then the energy that is flowing from region of higher temperature to a region of lower temperature is called thermal energy, right? So we are not actually figuring out, that temperature gets transferred in many different forms: convection, conduction, radiation. So we are not really bothered about how it is going to happen, but we are concerned about the fact that it is getting transferred from a region of higher temperature to a region of lower temperature. So this energy that is getting transferred is known as thermal energy, right? So when two objects are of the same temperature, there is something called a thermal equilibrium is being established, right? There is no net transfer of thermal energy between them when they are in contact with each other, right? So here what happens is, at this point, uh, in A, you can see that thermometer is cooler than water, right? So in both of the situations, water is at 60 degrees Celsius. So then what happens is, energy will be absorbed by the thermometer. So that means heat energy will get transferred to the thermometer, and the red colored liquid will start to rise up because it expands due to the absorption of heat energy. Then in the second one, thermometer is in equilibrium with water, meaning the thermometer is also at 60 degrees Celsius. So as a result, there is no net movement of heat energy, and there is no change in the volume of the red liquid inside the thermometer. So that is something that you must understand. All right. So these are actually quite basic stuff. You have learned in O levels as well, but it is important that you remind those stuff to yourself. So then the conversion of Kelvin scale into Celsius is another topic that you need to understand. So then that uh, thermodynamic scale is another name given to Kelvin scale. So that is what we use in scientific calculations, and there is a fixed point known as absolute zero. Absolute zero is minus 273.15 degrees Celsius, or 0 Kelvin, right? So it is not possible to have a temperature lower than 0 Kelvin anywhere in the universe. Uh, you know, but this is actually a situation when there is this, scientists agree that in a simple sense, there is no energy at all in it, right? Uh, but a different way of looking at this is actually, at 0 Kelvin, there is no possible way of removing any energy from it. The reason is, everything around us should have energy, because everything is made up of energy. Everything has, everything is made up of packets of energies. However, at 0 Kelvin, there is no way that energy can be removed from it. As a result, there is no thermal energy transferred in it. So that is the reason why we say that it almost looks like it doesn't have energy, right? The kinetic energy of the atoms or molecules is zero, and as a result, their electrical potential energy is minimal, right? So at 0 Kelvin, uh, we can use different symbols to represent temperatures on these two scales. We use theta for Celsius scale and T for thermodynamic or the Kelvin scale. Remember that as well. Theta is for Celsius, T is for thermodynamic or the Kelvin scale. Then if you want to convert theta in Celsius to T in Kelvin, you subtract 200, subtract 273.15, right? Celsius to Kelvin, right? Celsius to Kelvin minus 273.15. Then T in Kelvin to theta in Celsius, you add 273.15. Right. So in practice, what we do is we usually take it to be 273 because it is easier, obviously. Right. So then theta in this one, you have on the left hand side you have in Kelvin, on the right hand side you have theta in Celsius, right? So 0 means 0 Kelvin means negative 273 degrees Celsius. So what have you done? Here you have converted Kelvin into Celsius, then negative 273.15, right? So that conversion is something that you have already learned. So that is not a problem, I assume. So as a practice, remember the conversion. Remember these starting points, then it would be easier for you to make the connections. 0 Kelvin is negative 273.15 Celsius. The reason why we have Celsius and Kelvin is because now Celsius is quite easy to understand, obviously, because it is relatable to the boiling point of water, but still we can get rid of many problems of science using the thermodynamic scale of temperature. Because the boiling point of water and the melting point can actually vary depending on the purity of water, depending on the height from the sea level, etc. But absolute zero does not change. And also the liquid in glass thermometer being used can give many different readings depending on the material that is being used, and also it might mean that sometimes it might not be linear, so you have to be very cautious when using these readings. The thermodynamic temperature, on the other hand, do not depend on the property of any particular substance, right? That is actually, it doesn't really have anything to do with, because it has nothing to do with the properties of characteristics of water, right? Because the temperature of water, that we assume that when water is boiling, we think that it is 100 degrees Celsius, but if it is impure water, then that its boiling point is not exactly 100 degrees Celsius. The thermodynamic scale is said to be an absolute scale, as it is not defined in terms of a property of any particular substance, just like Celsius, which is defined based on water. It is based on the idea that the average kinetic energy of the particles of a substance increases with temperature. The average kinetic energy is the same for all substances at a particular thermodynamic temperature. It does not depend on the material itself. In fact, as you will see in chapter 20, the average kinetic energy of a gas molecule is proportional to the thermodynamic temperature. So if we can measure the average kinetic energy of the particles of a substance, we can reduce the temperature of that substance. So that means there is an interrelationship between the average kinetic energy of a gas molecule to the thermodynamic temperature, right? So there are two fixed points, absolute in Kelvin scale, absolute zero, which is 0 Kelvin, then triple point of water, the temperature at which ice, water and water vapor can coexist, which is defined as 263.16 Kelvin, equal to 0.01 degrees Celsius, right? 273.16 Kelvin, which is 0.01 degrees Celsius. At this point, ice, water and water vapor all three can coexist. So the gap between absolute zero and the triple point of water is divided into 273.16 equal divisions. Each division is 1 Kelvin. The scale is defined in this slightly odd way so that the scale divisions on the thermodynamic scale are equal in size of the divisions of the Celsius scale, making conversions between the two scales relatively easy. The reason why it is done is to make comparisons between Celsius and Kelvin, because now you know that 1 degree Celsius change means 1 Kelvin change, right? So in value form, 1 Kelvin, if there is a rise in 1 Kelvin, that is equal to a rise in 1 degree Celsius, right? Something like 1 milliliter and 1 cubic centimeter, they are both the same. It would be best if we write down a note. Please write down the meaning of temperature topic. When a thermometer gives us a reading, it gives it gives the temperature of itself. Leave a line and write. When the thermometer is placed in contact with something warmer than itself, thermal energy is transferred to the thermometer, which results in temperature of the thermometer, which results in the temperature of the thermometer increasing. The opposite will happen if it is placed in a cold liquid. This shows that energy is flowing from a region of higher temperature to a region of lower temperature. This is known as thermal energy. If the two objects are at the same temperature, they are said to be in thermal equilibrium with each other, and there is no net flow of energy, net flow of thermal energy between the two. Leave a subtopic, the thermodynamic Kelvin scale. Under that, right? Unlike the Celsius scale, thermodynamic within brackets Kelvin scale does not depend on a physical characteristic like melting and boiling point of pure water. Leave a line and write. It has two fixed points, absolute zero within brackets, the point at which it is impossible to remove any energy from matter, close brackets, and triple point of water, open brackets, at 273.16 Kelvin or 0.01 degrees Celsius, water can exist in all three states. Leave a line and write. 1 degree Celsius is equal to 1 Kelvin. Celsius is represented using theta and Kelvin is represented using T. Leave a line and write. To convert Celsius to Kelvin, you subtract 273.15 from the Kelvin scale and vice versa for Celsius, and write down these two key equations. Celsius is equal to T minus 207 Kelvin minus 273.15. T in Kelvin is equal to Celsius plus 273.15. So you can see an absolute zero is equal to minus 273.15 directly because T is going to be 0. Minus 273.15 Celsius. Right. I hope you understood this. If you have any further questions, please ask. I would suggest that you draw this figure 19.12 as well, conversion chart. That will help you to figure this out easily. Listen to this once, and if you have any doubts, listen again, and if you still have doubts, please ask me questions.